Hi, and welcome to this video on calculus. The goal of this video is to use a practical application to introduce the concept of definite integrals. So let's imagine you're traveling east for 2 hours at 60 miles per hour, and then west on the same road for 1 hour at 30 miles per hour. Now this is a problem that if you are an algebra student, you can do pretty easily, but we want to delve a little bit more deeply into this problem, and we want to think about how we could represent this graphically, and not only that, but how could we represent this situation using calculus. So hopefully the answer is trivial, right? If you go east for 2 hours at 60 miles per hour, you've gone 120 miles east. And then if you go west for 1 hour at 30 miles per hour, you've gone back the direction you came from for 30 miles, and that's going to get you 90 miles from your starting point. So we already know the answer. Let's think about how we can represent this situation graphically. Okay, if you're a calculus student, you've done a lot with graphs involving velocity and time. So we're going to make a graph that involves velocity, and I'm going to put the velocity on the y-axis and time on the x-axis. And I'm going to actually extend that velocity axis a little bit lower. So let's do that because we're going to need it to go in the negative direction. So let's think about the velocity. We need to go 60 miles per hour, 10, 20, 30, 40, 50, 60. So let's count by tens, and then we're going to go for 2 hours. So let's measure our time in hours. Okay, if we go 60 miles per hour for 2 hours, we have just covered 120 miles. You'll notice the area of the rectangle is 120. So we can represent the total distance we've traveled by computing the area under the velocity curve. Now, if we're going back in the other direction at 30 miles per hour, we need to think of that as a velocity of negative 30 because we are going back the opposite direction. So if west is positive, so if east is positive, then west would be negative. So we're going to go to negative 30, 10, 20, 30. And from hours 2 to hour 3, we're going in that negative direction. And if you always think about the area as the space trapped between the x-axis and your curve, that's going to be the area you're going to compute. So if we look at the area of this rectangle, we have negative 30 times the distance between the x values, which is 3 minus 2, which is of course 1. So that is negative 30. The negative indicates the direction we're traveling, and the 30 indicates the distance. So that is the area of that rectangle. And again, if we add those, the sum of those two values is 120 plus a negative 30, and that gets us our 90 that we had calculated before. So we've represented the situation graphically. Now let's think about calculus. Since we've just started doing integrals, we know that integral represents the space between the x-axis and the curve. So if I look at my graph, I can represent the first part of my graph as the distance between 0 hours and 2 hours. So my lower limit of integration is 0, my upper limit of integration is 2, and I'm integrating the velocity function, which is 60, with respect to time. So I'm going to use a dt. Then I need to add on my second area, which is the integral from 2 to 3 of the velocity function, which is negative 30 dt. Okay, so this is how we're going to represent this situation with integrals. I hope this video helped you make some connections between a practical application and how we might use integrals. Thanks for watching.